Hi everybody. I just wanted to talk a little bit about Medusa. So, one of the main problems that we faced was the take a message procedure. So, what was happening was, for the take a message, you have to be able to store different characters at different points in memory. But unfortunately, when you're writing this procedure, you can't change the memory location that you want to write to. So, instead, you needed the function to basically be written in RAM, so that way you could have a movable memory address. So what Jacob and I did was we wrote a procedure in ROM that the procedure basically wrote a new procedure in RAM when it was executed. And this procedure that was written in RAM actually allowed the memory address that we were going to save the characters to be incremented after each pass. So you'd put in like an A, and then it would change the memory address that you were going to save to the next one after that. And so this basically allowed us to have a movable and kind of dynamic program. Another difficult decision that we made was to have a stack or not to have a stack. There really isn't a right answer to this. Basically, it was a decision we made because we wanted to be able to jump around in the program and utilize the call and return functions. We needed to have that stack, but there are ways to work without it. One of the major things that I learned in this class was patience. For the first 8 weeks of this class, when we were just working on hardware labs, there were many times when we'd find like small issues and you just couldn't figure out what was causing it. And so this class basically taught me to slow down, really think about an issue, figure out what we know already and what we needed to figure out, what was going wrong. And yeah, so this was just basic debugging and figuring out where is the issue happening, do we double check everything, triple check everything. And yeah, so this was really helpful in learning how to find a small error, which I'm sure we'll use all throughout our life in programming. When working with software, one of the main things I learned was procedural thinking. So this is literally breaking down the code to its smallest steps and saying what's it doing here, what's it doing here, and really figuring out what each step is going to be doing. And this is really helpful in programming because it's very logical. You just got to understand what every step is what's happening in each step, and just figure out how you want things to work. The next major thing that software taught me was abstraction. So this concept is very crucial in the software side because there's so much microcode that if you had to program everything in microcode, it would basically be impossible. So by creating a layer of abstraction and writing these opcodes, which performed multiple microcodes, it made programming a lot easier. So for printing the menu, which would have taken basically hundreds of microcodes, we could now perform that by just calling a single opcode. Some future tips for software teams: really read each of the labs. Even if you have to do it multiple times, it really pays off tons if you really understand every single page, basically. You want to understand what the microcode's doing, how all of the opcodes fit into the picture. This will take you a solid week or two, but don't worry about the timing. You'll have plenty of time to program everything, but really read through everything. Another tip would be have everyone participate on microcode and assembly code. Your instinct is going to be to split people up to conquer everything. The divide and conquer technique isn't really necessary. You're going to have plenty of time to get to all of the coding, and it'll really pay off to have people understand both sides of the programming. This will pay off when doing the debugging Medusa, and it'll even help if you need to add a new opcode at any time.